Thank you again for participating, and this is a webinar dedicated to the solution, power supply solution, safety power supplies, and why it's important to use the power supply in the SIF. Some details about your host today. So we are here, Massimo and I. Massimo Pagani is our product manager in German International. Is our expert for new products and for assisting customers worldwide. Long experience in electronics, and is has a really complete overview on all entire GMI portfolio. Myself, Andrea, I'm working GMI since 2015. I'm account manager for major account. I was experienced starting in Europe with all distribution ship network, and now I'm responsible for account for main accounts. Just one information: please don't use your chat, but use a Q&A button if you want to make a question to us. And we can answer live also if it is possible. We already have some questions later on, so the presentation will be split in two parts. One part dedicated for real presentation and the other for Q&A. Some Q&A that you already wrote when you book your seat in this webinar. But in the meanwhile, you can ask anytime, and we try to answer live questions. Okay, so we can start. I want to start with a presentation, a very quick overview about the company. So GM International is a company that design and manufacture different products in with intention to be a safe company for very critical application, hazardous application, and safety application. For main market, oil and gas, chemical, petrochemical, and so on. We produce completely in our facility in Milan, but we have a global presence in all continents through our offices and distributors. So, let me, sorry, it was too fast. Okay. So this is our product range. We produce IS isolators, safety relays, isolator, power supply, safety power supplies, multiplexer for hazardous applications, termination boards for DCS manufacturers, hard multiplexers, surge protection indicators, and also, as long as we are talking about safety, we produce and we print out this kind of book, which is a manual dedicated for safety application. You can ask one copy for free. We send to you. It's not really a problem because we distribute all over the world. This kind of book is also available in electronic format if you need it. And our goals is really, say, to adhere to the most strict certification and the rules all over the world. We do have all kinds of certification for safety applications and also systematic publicity. Our employees are dedicated in R&D department, and we invest a lot of new products. The last but not the least is our 5 years warranty for all our products. As we say, we produce completely in Italy. We have complete traceability, full testing, and we are compliant with the ROS REACH directive. And some numbers: 8 subsidiaries, 78 distributors, 200 people working for GMI, and courses that we organize for functional safety, and a lot of installation all over the world. Some names about our major customers divided by system vendors, EPC, OEM, and users. This is our list of many customers. Of course, we have a lot that are small customers for, say, for critical applications. My part is finished for the moment. I'll leave Massimo dedicated to the topic of today. Massimo, you can continue.
Thank you, Andrea, for your introduction, and good morning again to our attendees. Well, now let's move on the presentation of topic today, which takes into consideration the power supply system and the value that they have within a safety loop. But before, I think we have a poll for our attendee, Andrea.
Yes, we have a poll, so we kindly ask you if you want to answer to this poll. It's a very simple poll, but it's very important to know what kind of customer we are in front of today. Okay, just 1 minute more and we will leave everybody answering. Okay, stop now, and we see that say most of you use standard power supplies, but a good part still rated and bought. Okay, we can go on, Massimo, with the presentation.
Okay, Andrea. Let's start by introducing the general concept of SIS, Safety Instrument System. SIS is a set of subsystems that make up the safety loop. Within the safety loop, we have field devices such as transmitters or sensors, which allow us to control, detect, and measure variables in the field, such as temperature, pressure, or other. They are driven by barriers or isolators that provide for limiting the current towards the hazardous area or to isolated field instruments. And in turn, the signals sent by the field loop will be acquired, managed, and interpreted by what is the brain of the SIS or the PLC DCR system, which will decide on any action to be taken to make a plan to save. And again, power interfaces as can be a safety relay, which will then act on a valve and on an actuator, which allow us to bring the system safety in case of need. The main concept that needs to be understood is that every single element of the SIS must be sized with a seal level, such as to allow us to obtain the overall seal of the SIS required. All the power supplies that will be part of the SIS, for example, those that will power the PLC DCS, those that will supply voltage to operate valves and actuators, those that will allow barrier, isolator, and transmitters to work properly, will also play a fundamental role in a safety-related loop. And it's also important that they also have an adequate seal level. All components of a SIS, including power supplies, must be safety related and have a seal level. This helps us to have a safety loop and with the core redundancy, a loop with high availability to the process. Next slide, Andrea. Now let's take a look at the power supply. What are the possible risks and conditions that we consider dangerous in relation to the use of a power supply? The concept of safety is very important also with regard to power supply system, because the failure of a power supply can cause serious accidents that lead to serious losses in terms of human lives, serious environmental damages, and serious cost losses for companies. For this reason, it's necessary to have safe devices that guarantee high performance. But what are the dangerous conditions for a power supply system? Well, mainly there are two dangerous fault conditions. The first one is an undefined load voltage in a range between 2 and 20 volts. Must be considered as dangerous failure of our power supply. This is because an incorrectly powered load works or can work out of specification. And this leads to a reduction in a load performance that can cause a premature instrument failure. Often we try to avoid this issue using redundancy, but we mistakenly think that two power supplies in parallel are sufficient to make us immune for possible fault in the power supply system. Redundancy cannot solve on its own and cannot guarantee us immunity from power supply failure, because a standard power supply system, it does not take into account the common mode faults that can afflict standard power supply. These common mode faults can cause spurious system faults with the related production downtime and which would significantly affect cost. The redundancy of power supply, safety power supply system minimize this risk because common mode failure are considered in SIF calculation, necessary to get the certification for a safety related device. The second dangerous failure condition of a power supply system is when the output voltage reaches a value higher than 30 volts. In this condition, the load is subjected to extra voltage, which can damage it. Or in case of output voltages higher than 50 volts, the field instrumentation can suffer a definite disruption. We can take, for example, an engine cooling system which works thanks to a standard power supply. Suppose that this standard power supply fails and goes into an overvoltage condition, damaging the cooling system. This will lead to an overheating of the engine, which will lead to serious consequences for the whole system connected to it. Once again, I want to underline that value of having a safety power supply system, which guarantees us high performance and high safety. Next slide, Andrea, thank you. So, why it's correct to use a safety power supply system? Below are in the main, below in the slide, we have the main reason that leads us to advise against the use of a simple standard power supply. A standard power supply is not designed based on the directives of ESC 61508. It does not have made a calculation defined for safety function to be obtained. It does not allow to have redundant protection from overvoltage issue, while in a safety power supply system, redundant protection are a fundamental requirement. And again, standard power supply can be used in a redundant configuration, but they do not guarantee that our application is totally safe for the reason related to the common fault, common mode fault, which we have seen previously. And also, standard power supply often require external or ring diodes to allow for redundancy. This means to add external wiring that, especially for high load currents, create a high voltage drop, which has a strong impact on the supply voltage. It's true that it's possible to adjust the output voltage to compensate for the voltage drop, but this operation increases consumption considerably. In addition, a standard supply system has a higher number of spurious faults than a safety power supply. We know well how a spurious fault can also lead to dangerous failures for the application. And also, standard power supply use internal components with limited operating range to keep costs down. This affects the lifetime of the device. For this reason, internally to the safety power supply system are used components with higher operating range that allow the system to work at a lower stress level. This leads to less failures and consequently a considerably longer lifetime than standard power supply system. Next slide, Andrea. At this point, why it's important to use a safety power supply system? First of all, we know that the standard voltage for a normally energized load is in the 20-30 volt DC range. As we have seen previously, conditions that lead to power supply output voltage between 2 and 20 and higher than 30 volt are considered dangerous failure, which negatively affect the application. Well, a safety power supply significantly reduces undetected dangerous fault thanks to a built-in diagnostic system. In fact, if an anomalous output condition is detected by the safety power supply diagnostic, it brings the output to 0 volts, which represents the safe fault condition. Plus, a fault transistor alerts the PLC system, which can act as per C specification. Even in case of a safety power supply output over voltage condition, the internal diagnostic activates the redundant protection system for limiting the output voltage, which brings the latter to a 0 volt. This means into a safe fault condition. Thank you, Andrea. Next slide. Now we introduce the concept of safety power supply applied to a typical application as DTS or ATS, de-energized to safe or energized to safe. As we know, typically the safety systems are designed to remove power to the system in case of the energized to safe application. Therefore, the failure of the power supply, which goes to 0 output voltage, is considered a safe failure. So we assume that all safety functions are DTS or DTT, the energized to trip type. Really, there are many applications where the safety function is to energize to load. Therefore, of the energized to safe or energized to trip type, as in a fire and gas system, a safety power supply is designed to guarantee a SIL2 or SIL3 safety level, also for energized to safe application, which need to energize the load on request. Well, for this type of application, redundancy and overvoltage protection are essential. Next slide, Andrea. A power supply redundancy system must be used when the safety of the power supply is essential. For this reason, the redundant power supply systems are used in critical sectors such as the oil and gas or pharmaceuticals, and in all those applications where the loss of power supply translating to the loss of sensitive information, or in all those applications where the certainty of having a correct power supply on request is fundamental. It must also be used in all systems where every minute of production downtime is extremely costly. Well, in the next slide, let's talk about system availability to the process. As we see from the slide on the screen, for de-energized to safe application, typically normally energized loads, the SIL-free safety level is easily reached through a type 1 of one configuration. For this type of application, we can achieve through redundancy an increase in availability to the process. This allows us a further quality step in guaranteeing production continuity at the plant and higher safety level. As regard energized to safe application, typically normally de-energized loads, as mentioned above, redundancy is essential to reach a SIL2 or SIL3 level. In fact, without redundancy, with a single safety power supply, only the SIL1 level can be reached, and also availability to the process is low. But by composing a configuration 1 out of 2 or 1 out of 3, it's possible to get a higher SIL level up to SIL3, and at the same time increase the availability of the process also for energized to safe application. In the next slide, we have some consideration about overvoltage protection. Overvoltage protection, as mentioned above, is fundamental in a safety power supply system because it allows us to reduce the risk of system downtime considerably. In fact, if one of the safety power supply fails in overvoltage condition, the protection brings the output to a 0 volts, allowing the other power supply system to continue working correctly without the risk of sending the system to shut down. A standard power supply without protection would cause a shutdown of the whole plant with the consequent repercussion on the productivity and cost. A SIL-free level power supply system with overvoltage protection is able to increase operational safety, productivity, and reduce costs. In the following slide, we see what is the weight that the individual subsystem have within a SIF. It's important that every single component of a SIF, including the power supply system, is included in the PFD-FG calculation to achieve the required safety level. Every single element has its own percentage weight, which must be considered. Below, we see other advantages. Next slide, Andrea, thank you. Below, we see other advantages that using a safety power supply brings. First of all, it can be installed in Zone 2, Division 2. This allows us to reduce wiring costs as it can be installed much closer to the load. More power in a small space with the use of a rack system up to 6 power supply inside. The rack system also allows us to reduce wiring costs and allow us to have the diagnostic module on board to control all the main function of the safety power supply system. It's also possible to connect via Modbus the diagnostic system to a remote system. Easy maintenance and troubleshooting thanks to the hot swapping system which allow the live replacement of an element in the rack without having to disconnect any connection. Operation in harsh environmental conditions tends to vibration test and extend temperature range up to 70 degrees Celsius. And as mentioned so far, availability for safety-related application up to SIF-free level. Here, in the next slide, we show the typical application where separate power supply are used as offshore platform instrumentation, fire and gas packaging, fire fighting system, and so on. Well, I finished my presentation, and now we have...
Before the pause, we have two questions, Massimo. First one, we use 24-volt DC book power supplies unit for powering solenoids in field and safety relays in marshalling cabinets. Is it the right things to do? Massimo, can you answer to this?
Sorry?
Can you answer to this question?
Okay, sorry. Yes, we... can you repeat the question, Andrea?
We use 24-volt DC bulk power supply unit for powering solenoids in fields and safety relays in marshalling cabinets. Is it the right thing to do?
But I think yes, power supply can be mounted in marshalling cabinet. We have some solution, a wall mounting solution, or a rack mounting solution.
So those are, this is the right, let's say, application for the customer. Okay, that's fine. What is the meaning of HFT in slide 21? Is hardware fault tolerance, means that the device can, say, I can have one fail in my configuration and still I have, let's say, assure my functionality. Okay, we answer also to this one. Let's continue. So we have, as you see, in push it, new poll. If you wanna answer to this. Takes just 1 minute and then we go on. Okay, we're gonna stop. So most of you use SafeR application, a big part also both SafeR and hazardous sign. Okay, so with this presentation we almost finished. There is another part we want to show you. So let's go switch to the new one. It is dedicated to question and answer. Massimo.
Yes, in the next short presentation, we have the question we are usually asked to us about today's topic. And
okay.
Well, and the first question is Is been 24-volt DC power supplies considered the fail-safe PFD equals to 0 and do not impact the safety of the SIF?
Okay, so it is very important things because, of course, it's not very true that all power supplies are fail-safe device with the PFD equal to 0. We already see, and Massimo explained, I think, very well, that situation 20-30 voltage is typical operating range for a power supply, and dangerous failures are when the voltage are higher than 30, because this situation can cause really problems on your instrumentation. So in this case, it's very important have redundant protections that block and stop the voltage higher situation than 30 voltage. So we have seen that the 30 voltage, more than 30 voltage is very critical for the system, but also output condition when it's between 2 and 20 is also critical because the loads is working out of specification. You can have malfunction, you can have some situation where the instrumentation is not working properly. And in this case, you can avoid this situation by introducing redundant power supplies, but also you are taking account that there is also common cause failures, and there is I think you are aware about the beta factors. So same instrumentation, same devices in a redundant system made by the same manufacturer with the same typology and so on, same batch, can fail at the same time. So this is also a risk. And in case of redundant also, you can have that, and if you have one power supply is connecting, the redundant is leading, is working in between 2 and 20, can lead all the power supplies working at the same under voltage condition. So there are different situations that can also you can have on your system in the 220 volts. Okay, so there is another question.
Another question, typical question is how power supplies can influence performance of a system and what is their design and preventive maintenance requirements?
Okay, good. So, the SIS, of course, is designed to say to lose power. So the energize to trip functionality. So it means that your hardware has to be able to reach a safe state. But the problem is that in a certain factory and so on, you cannot reach this off state. So the power has a dual role in safety. So it must be really reliable. So the overvoltage has to protect your instrumentation. We had this experience, in the switching power supply inside we have a 400 voltage, and that is a typical circuit inside of switching power supplies. And this we have experienced that this 400 voltage went directly to the loads. That this burned completely the systems. And this is a really unwanted situation. But if you use a system with a over voltage protection outside, this will be protected. And over 30 volts will be a dangerous failure and it will be stopped completely. So, and also the power supply needs to be available and must be redundant with the load sharing is a really common practice used in industries. So we know also, and also the preventive maintenance and the testing proof. If you have situation where you are using seal device, this seal certification is valid for certain number of years, depending on the hardware, depending on the application. But this is and the probability different demand degrades sometimes. So will be the risk for a failure. It will be higher by the time. So the more time, higher probability for demand. If you want, of course, return to the initial situation, the hardware must be tested after certain year. This certain year, this is a testing proof, is specified well by the in the safety manual supplied by the manufacturer. So,
thank you, Andrea. Another question as in regard to the safe and dangerous failure and the possible difference between them.
okay. So this is a safe failure and a dangerous failure. So we say that safe state is, we already said a lot of time, I hope it's clear now for you, that when the power, when the output voltage is in the range of 20-30 volts. So dangerous state is different because it's when the output is below 20 or higher than 30. So different voltage, different situation. So, and the state certifications, of course, wants that this probability of failure is in the certain level. Okay, for instance, so, and the overvoltage protection grants this situation that is the hardware is not, or the power supply is not giving, is not leading to a dangerous situation. If you want, of course, increase the cell level, you can do by 1 or 2 redundant hardware power. So, for non-energized, a single power supply is sufficient for CL3 without any redundancy. But if you want to increase the availability, you can use one or more power in parallel. So the second power supplies in the CL3 configuration for non-energized grants the availability for the more availability. But in case, indeed, if you're using an application which is normally energized, for normally energized, the redundancy is important to increase the cell level. Otherwise, your cell will be will remain at level 1. So next question, I don't see any question from people. Okay, good.
Okay. Another typical question that is often asked of us is what is the difference between safety and availability?
Yeah, we already introduced a few times. So in IS6 61508, for a manufacturer or for your point of view as the users, IS6 61511, only safety is considered in the norm. So that is very important because, of course, safety is the most important thing. But as users, as a system integrator, you are facing with availability, and availability must much more from the user, of course, because is the proportion of time for which the equipment is able to perform its functions. So availability is different from reliability. So it takes time to take into account. So availability means that my system is working properly, is working at the condition I want without any spurious or nuisance trip. Okay. So availability is very, very important because I cannot, in a new system, in a modern system, the failure is not accepted. You cannot stop your plant because your hardware is failing. So Beside the safety, availability is a factor that is really required, because one day of, say, where your plant is stopped, maybe can cause a million of damages, million of say, euros, dollars loss. So, and this is a configuration we already show you, but I want to repeat. I want to, let's say, remember that for non-energized load, if you're using safety power supplies, the SIF3 is already reached by using just one power supply, no redundant, okay? So you reach the safety, but you don't reach the availability. It means that HFT was the question from the one attendee before. HFT is zero if you use just one power supply. Why? If you use a redundant power supply, the seal level remains seal free. You don't increase it. That is the very highest in the industry requirements. And but using two power supplies, you can increase the availability, meaning that one power supply fails, the other takes over. The difference in normal de-energized load is quite important, because for firing gas, for instance, use just one safety power supply, because the seal you reach if you use just if you use a safety power supply, not standard power supply without F-mega calculation. With one, you reach the seal 1, okay, level, no redundant. If you use two redundant power supply, you reach a seal 2. So you see that redundancy is important for normal energized, for ESD, for instance, for increasing availability. While for normal energized, firing gas is important for increasing the safety. Okay, so maybe there is a question from one attendee.
Yes, Andrea, we have a question in regard the diode or ring. In case of a redundant power supply with a diode or ring circuit, what is the way to ensure the reliability of the diode itself? Is the diode fails is tech power supply redundancy defective? It's considered a single point of failure. But I think that for the power supply system, safety power supply system, the circuit regarding diode or ring is inside in the power supply system itself, and it's inserted into the calculation and considered and controlled by the diagnostic. While in a standard power supply, it must be considered in a SIF calculation, and I think it's a problem for redundancy. But I want to ask our team engineer in respect to this question and answer.
Yeah, we can answer better to this one later on if you agree. We don't have your details if you wanna, because it is anonymous information we see now. If you wanna send us your email, we'll answer properly. But the thing is, it's true. So basically, the standard also safety power supply from other manufacturers, not GMI, needs dive ring out circuits for redundancy. And this is really, as long as it is also power consuming, is the risk of failure is high, and maybe you can incur in problem for the power supply system itself because of this diode system. Now, the diodes are inside, but it's not really diode. It's a electronic circuit, much more, let's say, reliable. But we will send, if you want to send us your email, all details.
Okay, thank you.
Okay.
Well, other consideration is about sea levels and possible configuration.
Yeah. This table is for non-energized load. Is an example we made for non-energized. We have just one, just our PSM 1250, and this is for 10%, 20% of the SIF. We are taking that it's CL3 one from non-energized, just one. Okay, it's a CL3 for 1.5 year with this. With 10% of SIF, or 3 years. It means that they can stand in the application for three years, and with the 20% of the SIF. Why you can use, that is another question, also for CO2 applications, the CO3 power supply, because CO2, you're extended this activity. It means that you want to assure just a CO2 level your loop. Then you can use for 18 years or 20 years, respectively, with the 10%, 20% of the SIF in the CO2 application. So CO3 power supply can be used in CO2 application, and in this case you get a lot of advantages for the let's say, testing proof or the let's say you can use it without test the device for a really long time. You see that our limitation is 20 years because 20 years is the lifetime of the device. So in the same normal energized load, you can use two parallel power supply. You can stand a lot the T-proof for the 10% and also for the 20%. For parallel, again more, okay. For the 10%, the 20% is a little bit lower, and the 6 parallel as well. So I increase, it means that this table means that maybe the safety won't be increased so much if I use much more devices in parallel, because if you remember correct, just one power supply is enough to reach the safety, but of course increase a lot my availability. There is an example also for normal de-energized load here now, and I see that for a single power supply, is just a value for CL1, 1 year or 2 years, and you want 10%, 20% of the C. 2 or more parallel is valid for 2 years for CL2, and in 2 years for 10% of the C, for 4 years with the HS, this time the hot swapping, and 20% of the SIF. So more devices increase safety and increase also availability, especially on normal de-energized. Okay.
Okay, well, another question is a safe power supply shall be used for the system that only participate in a SIF.
Of course, this is, we want to answer the other way around, because for all system in a SIF, a functional safe power supply must be used. And this is not done usually in industry application. It's very important because the function safety parameter is must be considered with other function safety parameters for the other devices in the SIF. So it's very important that you obtain from your power supplies manufacturer and have made a calculation with all details. Of course, for all the other not function safety related systems, normal power supplies without, say, safety parameters can be used. There is a question, Massimo, I guess?
Yes. Our attendee asked to us if safety power supply from GMI are process safety application. Are these GMI power supply also certified for use in machine safety application? I think that machine safety application have a specific certification, and we ask to our engineer from the certification for this specific question, Andrea.
Yeah, machine safety is another, we can answer, let's say briefly also, not completely, but machine safety is another kind of certification, is a PI probably.
Yes.
And we experience with the safety relays for machines that are completely different. But I would say that, Massimo, you can say that for machine safety is also, there are not specific functionality except the reliability and the safety of the power supply. So, of course, power supplies must assure power for a long time without stopping, without spool sleep, without and protecting machine from unwanted overvoltage or low voltage. So I would say that is probably also could be useful also for machine safety applications.
Yes.
But maybe also in this case, we ask you to send us your details because you are anonymous and we don't see your emails. We want to get a proper answer more in detail.
Okay, Andrea, another question is there any solution for installation in hazardous area?
Well, also in this case, we can say that hazardous area, the limitation for the power supply is for zone 2, and the power supplies, of course, we have a solution 20 amps, 50 amps in the rack and so on, who certify for installation in directly in zone 2 or division 2. That is one possibility also. And I see that a lot of you asking also for this or using power supply in hazardous application. This is very important because the advantage is that you can install the power supply direct closer to your loads. Also, from the wiring point of view, you can get a lot of advantages because wiring will be shorter and it's also connection will be simpler with your loads if you use direct power supply in your hazardous area. Okay, so, and also another point is this one. So, another feature that we can offer is hot swapping. Hot swapping in zone 2 or division 2 that is assured by micro switches that detect the module presence. And there is ASG disconnect AC input, pre-open to contact relays. So there is a really control and it's certified devices to be hot swapping in hazardous areas. So in case also, this is another point that Massimo mentioned in the one slide before, the possibility of make your, if you're using a rack mounting power supply redundant, and you need repairing, you need test and so on, or one unit, you can say without disconnecting the power, you can remove one unit and the other unit, the other or the others will take over the power supply. Your system will be always on. You have the time to repair or replace the module damaged.
This is the hot swapping system is mandatory for installation in a hazardous area.
That is another point. Good. Okay, so
Another question regarding as a diagnostic for power supply with Modbus interface.
yes, also we talk about the rack mounting, and the rack mount is the unit here you see on the top pictures, where there is the side is the diagnostic modules that offer in Modbus interface Modbus communications, so it can be interfaced with your DCS or safety PC you are using, if this is communicating over Modbus, but it's a very common protocol, so I'm sure that most of you can handle this kind of protocol. Parameters beside the display, local display, where you can have all details about the module connected. The monitor parameter over Modbus can be like AC, high voltage, current, power, frequency. There are a lot of registers, DC output, current sharing, temperature, fault conditions. So you can also have a logging of the system. There are a lot of parameters because Modbus offer a lot of possible registers that can be acquired on your system for diagnostic. Massimo, you want to say something about that, maybe, or not?
No, no.
Okay.
Well, another question that often our customer placed to us is comparison between redundant power supplies, rack or classic wiring.
Well, also in this case, there are two possibilities. For instance, let's talk about standard redundant system is on the right side. You have two power supplies, and outside basically you have the O-ring that one RTD was mentioned before, O-ring diodes for redundancy that needs to be connected if you want to parallel the load shedding for the power supplies connected. So of course, all wiring is external if you use standard redundant system, the right side. There is the maintenance required the wiring, so you have to disconnect first the power, all the wire, everything, and then you can maintenance. Of course, it's better in price. The price is more competitive. But there are, of course, these external diodes for redundancy that is maybe can be bottleneck for your application, because this is also can be damaged, not frequently, but with high probability. While if you use a rack system on the left side, the power supplies are already parallel, so you just you don't need to parallel yourself. Okay, the maintenance don't require wiring disconnection. It means that I can take out, I can remove one module inside the diagnostic you see on the right. I can module one module, and the other will take over the power. The connection, this connection is also during normal operation, if there's a stepping, also in zone 2 or diff 2. And there is also this kind of diagnostic module available. So there are two different schools of operations, but you see the differences. And the difference is mostly in the wiring and also the, let's say, the O-ring diodes for redundancy. Okay.
Well, Andrea, to conclude our presentation, what happens if one device connecting to the power supply shorts?
This is specific features we implement is in case of a short circuit, if you have the power connected to different loads, in case of short circuits, this kind of power supplies is able to deliver very high peak of current. We are talking about 800 amps for a very short duration, 0.5 millisecond, and this is it's enough to guarantee the instant opening of the protective fuse or circuit breaker. So it's this scan will be delivered exactly to the load that is causing the shorts. This will open the fuse or open the circuit breaker for the loads. And so in order to maintain the other equipment connected to the power without affecting the, let's say, the system, the other loads from the short circuit you got on this kind of load. So this is another special features. We basically finished. Don't see any live question from you. I remind you that the other live webinars is on our website. You can see different topics like such as we're talking about Zener barriers, isolators. We're talking about safety relays, application for safety relays, life cycle for SIS, and so on. Other really interesting topics about functional safety. If you want to also look, there is also a link for the past webinars. You want to look yourself and maybe review this webinar or others. Any of that has been recorded and it's available on our YouTube channel. I see there is a question. Last one, maybe. Do you recommend 24-volt DC bus or to avoid failure to all field instruments in case of grounding? Okay, Massimo. I think maybe it's better for you this.
Yes, especially I think that to avoid failure is better to use bus in a rack to allow us to use the diagnostic of the power supply system and to take of under control the failure of the line.
Yeah. Okay. So we answer so this one. Don't see further question. Okay. We have the last poll. So if you wanna rate, we'll be really happy to hear what you say. To maybe we can improve something in our exposition, our, let's say, slides and so on. Thank you for answering to us. Remember that you can also, for the open question, please send us an email with your question. We will answer properly. Maybe the time for the webinar is not sufficient to answer properly, so especially to certain questions. So we want to take the time and maybe discuss with our R&D team about that. And okay, you are very good when you answer to us about this webinar. Thank you very much. Thank you very much. I'm gonna stop. And so we finish. We remember you our details, our names, and our emails, and the phone and so on. Thank you for your time. Let's see very soon. Thank you, Massimo. And keep in touch. Thank you. Bye-bye.
Bye-bye.